This video is going to be a bit longer than normal. It's going to be Theorem 1.024, and it's angle similarity. It says that, let's see, given a correspondence between the vertices of two triangles for a triangle and itself, if the corresponding angles are congruent, then the triangles are similar. And the proof of this is going to be quite a long one. Actually, before I get this started, I'm going to go ahead and scroll down. Hopefully if I draw the triangles at the bottom right here, I won't have to draw them again, but maybe I will. So these are going to be the two triangles that we're going to prove everything with. So we'll say given triangle ABC and triangle DEF. So let's label these A, B, C, D, E, F. And opposite those, I'm going to make these sides. By convention, the points are always that where two sides meet, or the uppercase letters are where two sides meet, or their points. And the lowercase letters represent sides across from their uppercase letters. That's a convention that's used in math, and it's one that I'm going to stick with. We'll say angle A congruent to angle D, angle B congruent to angle E, and angle C congruent to angle F. So we want to prove that these are similar. And say that by angle construction, there exists a point, we'll call it point G, that's the next letter. There's some G element of the ray ED, such that EG is equal to C. So we have some kind of G right here. We'll say it's right here, but such that this length is equal to this length right here. Also, there exists a point H such that, or point H element of EF, need to do all this in the same order, such that EH equals A. So the point H, will say it's here. Hopefully you don't get that confused with D. D is the whole side, H is the single point. Then triangle ABC is congruent to triangle GEH by side angle side. Then by corresponding parts, of congruent triangles, angle EGH is congruent to angle A. Then angle EGH is congruent to angle D. Since angle EGH and angle D are corresponding angles, and are also congruent, we can say that GH is parallel to DF. Then by a previous theorem, C over F equals A over D. And then, yeah, we'll go ahead and do the rest of it. The rest of this, we'll just make a note here saying rest of proof is similar. But we'll actually go ahead and do it. So we'll say, as before, there exists some type of J element of the array FD. So we'll put, probably need to switch to orange to do this. We'll put J down here. So J is an element of the array FD, and I element of FE. Such that JF equals B and IF equals A. Then we can say that triangle ABC is congruent to triangle JIF, congruent to triangle JIF. Then ji is parallel to DE. And therefore, B over E equals A over D. Since we already have, actually we'll spell that out. Since we already have C over F equals A over D, then A over D equals B over C equals E over F. So triangle ABC is similar to triangle DEF. I might as well draw in some of the stuff that we have. Let's see, these two angles are congruent. Make these two angles congruent. And these two angles are congruent. Then we'll draw in some of the lengths. Let's see. This right here was B. This right here was A. And I think that's everything. Oh, forgot the most important part of the proof. The ending of it.